In this video, we'll be looking at the Allen's ratio test. The Allen's ratio test. Now, we'll proceed by giving a brief description of the Allen's ratio test by saying L is equal to the limit as n tends to infinity, the absolute value of u sub n plus 1 over u sub n. If L is less than 1, we say that the infinite series converges. If L is greater than 1, we say it diverges. And if L is equal to 1, we say that it's inconclusive. And then we move ahead by looking for the sum of the infinite series by comparison test or any other test that you have in mind. Now, we proceed by this example. We check for the Allen's by using this example. Given the infinite series as the summation of n equals 1 to infinity of negative 1 raised to the power of n over 4 raised to the power of n of x plus 3 raised to the power of n. Now remember, we're making use of ratio test, so we proceed by saying u sub n is equal to negative 1 raised to the power of n divided by 4 raised to the power of n of x plus 3 raised to the power of n, which is for u sub n. Then we proceed by looking for u sub n plus 1, which will give us negative 1 raised to the power of n plus 1 of n plus 1 all over. We have 4 raised to the power of n plus 1 and x plus 3 raised to the power of n plus. So continuing in the same manner, we will now say that L is equal to the limit of n as it tends to infinity of the absolute value of negative 1 raised to the power of n plus 1 of n plus 1 over 4 raised to the power of n plus 1. Then we have x plus 3 raised to the power of n plus 1 multiplied by 4 raised to the power of n over negative 1 raised to the power of n, and then we have x plus 3 raised to the power of n. Now we can see that this is very easy. This is very easy, as you can see. So the next thing for us to do here is that we close this absolute value. We now say L is equal to the limit as n tends to infinity of negative 1 raised to the power of n dot minus 1, and we have n plus 1. Then we have x plus 3 raised to the power of n dot x plus 3 all over 4 raised to the power of n dot 4. Now this is multiplied by 4 raised to the power of n over, we close the absolute value. Then we have negative 1 raised to the power of n, then n, we put this n in the bracket and say x plus 3 raised to the power of n. Now 4 raised to the power of n cancels out 4 raised to the power of n. Now x plus 3 raised to the power of n cancels out x plus 3 raised to the power of n, and then we have this cancels out this guy. Yes, so now we are left with L is equal to the limit as n tends to infinity of the absolute value of negative n plus 1, that is x plus 3 all over 4n. Now what we do now is that x plus 3, we bring it outside. So we have the absolute value of x plus 3, then the limit as n tends to infinity of n plus 1 over 4n. Now the limit of n plus 1 over 4n is just simply 1 over 4. Then we'll quickly do that in this box here. We have the limit as n tends to infinity of n plus 1 over 4n. Now what we do is that we divide all through here. We divide all through by n, meaning we have n divided by n plus 1 over n all over 4 over n. Yes, then we divide. You'll see that we'll be left with 1 over 4 as our answer. So therefore, we have our answer to be 1 over 4, the absolute value of x plus 3. Now, since we know this is our answer as 1 over 4, the absolute value of x plus 3 to be less than 1, we assume it to be less than 1, which is said to be convergent. Now, we have to look for what we know that it really means to be convergent. Now, we proceed by saying that if 1 over 4, the absolute value of x plus 3 is less than 1, now what we'll do now is that we'll say that this implies that the absolute value of x plus 3 is lesser than 4. Now the series converges. But if we have x plus 3 greater than 4, we'll say the series diverges. Now, since we have this, we can see that if the absolute value of x plus 3 is greater than 4, the series diverges. But if x plus 3, the absolute value, is less than 4, we say that the series diverges. Thank you for watching this video. Please like, share, and subscribe.